What is caramel? Caramel is a medium to dark orange confectionery product made by a process called caramelization and is used in many foods such as ice cream, pudding, popcorn, etc. Caramelization is the browning of sugar, a process used extensively in cooking for the resulting sweet nutty flavor and brown color. As the process occurs, volatile chemicals such as diacetyl are released, producing the characteristic caramel flavor. The brown colors are produced by three groups of polymers: caramelins, caramelins, and caramelins. Caramelization is a type of non-enzymatic browning, similar to the Maillard reaction. Although it may seem like a simple process of heating sugar, it is actually quite complex that include multiple reactions listed here. So what is actually happening to the molecules inside caramel? Well, the main ingredient for making caramel is sugar, also known as sucrose. Upon heating, sucrose decomposes into its constituent monosaccharides, glucose and fructose. There are two methods on how to make caramel. The dry method only uses sugar, and the wet method uses sugar and water. Although the dry method is faster, it runs a higher risk of uneven heating of the sugar. The wet method allows the sugar to heat evenly as it is dissolved in water. The degree of caramelization that occurs varies according to the amount of sugar used, the length of heating time, the type of sugar, the addition of other ingredients, and the temperature the sugar reaches. Caramelization temperatures vary from 110 all the way to 180 degrees Celsius. Caramelization reactions are also very sensitive to the chemical environment. The reaction rate can be altered by controlling the level of acidity. The rate of caramelization can be accelerated under both acidic and basic conditions. The rate of caramelization is generally lowest at near neutral acidity. When the sugar solution starts boiling, avoid stirring as sugar molecules prefer to sit in a crystalline structure. Further agitation may lead to push the molecules together and allowing recrystallization to occur. Adding milk and butter also prevents crystallization, as the milk proteins and fat act as interfering agents by getting in the way of sucrose molecules, whilst giving the caramel more flavor. You may also add other interfering agents such as inverted sugars. They contain fructose and glucose molecules that block sucrose from recrystallizing. Acids. They cause sucrose to break up or invert into its simpler components, fructose and glucose. Gelatin. The starch will swell in water and form a stress on the sugar crystal structure. Honey or brown sugar. Honey has a non-crystallization property, and brown sugar alters the ratio of glucose to fructose.